Okay, on this video, I'm going to talk about limiting reactant. So that's the next concept that I want to cover, limiting reactant. And I want to start by giving an example from real life, and then we can go to the chemical example. For instance, you want to make a hot dog, and you have two slices of bread. Let me make a two slices of bread and you want to combine with the hot dog itself and you have this one. The question is how many hot dog can you make with two slices? Okay, this is just two pieces of bread here and two hot dog. Well, if you are making like a standard hot dog, because I know some people want to make it a little bit different, you will do the following. You get the two slices of bread, right? And put the hot dog in the middle, right? And then you have leftover one hot dog. So limiting reactant will be the substance or the in this case the bread that will be the limiting reactant because when you run out of bread you cannot make more hot dog uh, after that. So this one will be the limiting reactant and this one will be the excess because the proportion is two slices of bread versus one hot dog and one leftover that will be one hot dog will be leftover. So in chemistry uh, it's almost the same. You have a proportion between the reactant that obey the balancing chemical equation, the combination that happen between the substance, and some equation you need to calculate the limiting reactant. So let me go over one real life example. Again, I'm going to use the water, which is the easier one, and I'm going to use mole. Hydrogen plus oxygen gas producing water, and that will be water liquid. And we need to balance, always need to balance before doing any calculation of limiting reactant or product or anything like that. So let's pretend that theoretically I had 3 mole, I put together 3 mole of hydrogen reacting with 7 mole of oxygen. Let's find the limiting reactant. One way to find the limiting reactant is checking which one of them is the one producing the least amount of water. I forgot to finish the balancing because I was trying to figure out the number, but let me do the balancing now. Two hydrogen here, two hydrogen there. No problem. Two oxygen, one oxygen. Let me place a two here to make two oxygen. And now I have to put a two here, making four hydrogen, and that will be balancing. So going back to the limiting reactant, we need to do the following. Um, What will be the substance, hydrogen or oxygen, that produce the least amount of product? Let's start with testing hydrogen. Based on the balanced chemical equation, 2 mole of hydrogen will produce 2 mole of water. This is a simple calculation, but let's try hydrogen. So the proportion is 3 to 2, and I will call X. I will find how many mole of water can be produced. X over 2. Solving for X, that will be 3 times 2 over 2, and cancel out, that will be 3. So we can get 3 mole of water when we put together 3 mole of hydrogen, assuming this is the only reactant. So let me check now how much water can I get with the oxygen. Based on the stoichiometry, 1 mole of oxygen is producing 2. So I will call y another variable, and I will make the following proportions: 7 over 1 equal y over 2. Solving for y, cross multiplication, 7 times 2 that will be 14 mole of water. Which one is producing the least amount of water? The one producing the least amount of water will be hydrogen because it's producing three. So when the hydrogen finish reacting, the reaction will stop. So this one is the limiting reactant. And this one is the excess, right? And one question sometimes that you will find in any uh, test quiz is asking you what's the theoretical yield. The theoretical yield will be the amount that you can get from the limiting reactant. So using this form, I can easily say theoretical yield will be 3 mole of water. That's the maximum amount of mole that you can get, because when you run out of hydrogen, you don't you cannot get more water. But of course, to make more complex this problem, sometimes they don't ask you for mole because we don't have any device in the lab for calculating the mole. So indirectly we need to find, we need to find the mass, and we use the mole for finding the mass. So how many grams of water can we get on this problem? Okay, the way we'll be doing that is using the formula number of mole of water will be equal to the mass of water over the molar mass of water. And we need to find mass of water. Why is that? Because the problem is no, don't give me the mole, just find the mass, because we can then using a lab density or a balance to find the mass. So number of mole times the molar mass, that will be the mass of water. Number of mole of water is 3 because already calculate. And just let me refresh how to find the molar mass of water. Let me make on this corner. Mass of water will be 2 times the atomic mass of hydrogen plus 1 time the atomic mass of oxygen. So that will be, looking at the periodic table, atomic mass of hydrogen is 1.1. So I need to multiply this plus, I can round, is 1599. I can round to 16. So the answer will be 18 gram mole. So multiplying 3 times 18 gram over mole and mole cancel out, and I go 3 times 8, 24, carry 2, and 3 times 1, 3, and 2 will be 54 gram of water. And that's again is theoretical yield. The only thing is in gram. And that will be the way we do the theoretical yield. Okay, one more question related to that. How about you are doing an experiment in the lab and you go your reaction hydrogen oxygen, and your experimental one, when you go and calculate the mass of water, experimental one, you obtain, let's say, 20 gram of water. That's your result after doing the experimental. One of the questions that will ask you is percent yield. What is the percent yield? The percent yield is the actual over theoretical times 100. Using this formula on the example given to you, experimental equal actual. So you will be 20 gram is your real mass of water that you obtain in your experiment over The theoretical that was 4 gram of water. Both are water, okay? Because you obtain water on both time 100. And then you divide 20 over 54, and the answer was 0.3703. Multiply that by 100, your percent yield is 37.0303%. And that's another question or calculation you need to do when working with chemical reaction. Okay, summarizing, let me make it smaller this one. The first thing that I need to do is balancing the chemical equation. Without balancing, they gave me mole, and I can find the limiting reactant. The limiting reactant is the one producing the least amount of product. And I base my calculation using the balanced chemical equation and the coefficient that I go after balancing. Then after that, I will find the theoretical yield in gram, which is 54, because let me redo the calculation just in case, because I didn't use the calculator. So let me make sure 3 times 18. Yeah, I think it's the right one, but just, yeah, 54, just making sure that. So that will be your theoretical yield in gram, because this one is theoretical yield, but one is expressing mole and the other one will be expressing gram. Another question will be finding the percent yield, and you divide the actual. Actual is the result that you get from your experiment, the real thing that you get. And the theoretical is the one that you calculate using the balanced chemical equation with all the stoichiometrical combination. And then you divide actual over theoretical and multiply by 100. And you go a lower percent of yield. Most of the time, you will get a percent yield less than 100, unless there is an error in your lab or the product is wet, but that's another situation. Most of the time will be less than 100 or equal 100, your percent yield. And those are the calculations you need to learn from uh, chemistry in order to understand stoichiometry and work on a stoichiometry problem. Thank you for watching.